Hi guys, welcome back to my channel Programming at Pirai. In this video, we are going to see about Juspay last year question. Maximum weight node. Given a maze with n cells, each cell may have multiple entry points but not more than one exit point. So these are unidirectional. So which means a edge is connecting from one cell to the next cell is a unidirectional. You can go from one to another. We cannot use by using that edge, we cannot move from the next part to the previous part. Okay, so it is unidirectional. You are also given an array exits where exits of I contains the exit point of the ith cell. If exits of I is -1, then ith cell does not have an exit. So it means if at the 0th index, if it is 1, it means from 0 to 1 there is an edge. That's it. The task is to find the cell with maximum weight. So the weight of the cell I is the sum of all the cell indices that have the exit point as I. If there are multiple cells, then what should I return? I should return the highest index. The cells are indexed with an integer value from 0 to n-1. So this is the another useful thing. A cell I has weight 0 if no cell has exit point as I. Okay, fine. So let us see the example so that it is more clear. See here, this is the example 2 0 -1 2. So it represents like from 0 to 2 there is a edge. So that's why from 0 to 2 there is a edge. From 1 to 0 there is an edge. And then for 2 there is no edge, no outgoing edge. That's why it is -1. So that's why there is no outgoing edge for this 2. Now for this 2, sorry, for this 3, what is the outgoing edge? It is 2 2. So from 3 to 2. Can you understand this? Okay, now from this I can say the weight of the 0 is 1 because 1 is pointing towards 0, right? Anything else pointing towards 0? No. So weight of the cell 0 is 1 and weight of the cell 1 is 0 because there is not incoming edges. And then weight of this cell 2 is what? 3 plus 0, which is equal to 4. Sorry, which is equal to 3. And then what is the weight of this 3? It is 0 because there is no incoming edges. Okay, fine. So see here, if it is -1, they have given -1, which means 0 does not have any outgoing edges and also incoming edges. That's the meaning for this. Okay, so it will be what? 0 only. So also they have given that there is no self loop. I saw somewhere. So there is no self loop. Okay, which means 1 cannot point to itself like that. Okay, fine. Let us understand and solve this problem. Just see here, this is the first example. In first example, they have given that 2, 0, -1, 2, which means 0 is pointing to 2 and yes, then 1 is pointing to 0, then 2 does not pointing to anything and 3 is pointing to 2. Hope you understand this. Okay, fine. Now, what is our core logic is, we want to take another array filled with 0 0 0 0, and this will be 0th index, first index, second index, third index, which means this nodes. Okay, now first of all I want to just take one by one. I will take this. See here, this is how we will represent, like this is how we will visualize, but ideally we will implement by using this array only. Okay, it is simple. It is not like a graph problem. We can do without any knowledge in a graph. We don't want to apply any algorithm, basic DFS algorithm. We don't want to apply. This is for your understanding. I just drawn this diagram. Okay. Now see here, I am at this 2. Okay. Now 0 in this containing 2, which means what? Which means 2 should be added with 0. So I will add here plus 0. It remains 0 only. Okay. Now I will go here. So which means what? At 0 I want to add what? 1. So at 0th index I want to add what? 1. Okay. Now here this -1. Skip it. Now come here. So it is what? It is like from 3 to is from 3 to 2 there is an edge, which means what? We want to add 3 to second index. So add 3 to the second index. Now come back to this array, check whether it is a maximum value. Just assume the maximum value is 0. Now it is 1. So update this as 1. Then it is 0. So don't want to update. Now come here. It is 3. So update as 3. It is 0. So don't want to update. Go here. End. That's it. So what is the answer? It is 3. Sorry. It is 3 and which contains this 2. So you want to return this 2. Okay. So this is the basic implementation. I will tell you by using a dry run also, by using this example. Okay, let us see this example. So in this I will tell you how exactly the working is. Okay, so this above path is just for a implementation, for a basic implementation. So see here, 0, 1, 2, 3, 4, 5, 6, 7. So these are the indices. So it represents us from 0 to 3. That is a node. Sorry, that's a edge. Like that for everything. Okay, just understand by using this diagram. Okay, what I told you we want to also put 1, 2, 3, 4, 5, 6, 7. Okay, 0, 1, 2, 3, 4, 5, 6, 7. That's it. Okay, so first we want to put this array. Then what is our second step is I want to take this as a first element. Now what it indicates from 0 to 3. So I want to add what? I want to add 0 to this third index. So 0. Okay. Now come here. It means from 1 to 0. This means what? I want to add 1 to this 0. 0th index. Okay. Now it implies I want to add 2 to this 0th index. So it is equal to 3. Now it implies from 3 to 5. Which means I want to add 3 to this 5. Okay. So come here. It is what? From 4 to 3. So which means here I want to add 4. Then it is -1, skip it. So come here, it is what? We want to add 6 to this 3. So it becomes what? 10. Now come here, it means we want to add 7 to the 0th index. So which means here 10. Okay, so this is a finding. It is a finding. Okay, now I will take an index. I will take the index as 0, which means I am just deciding 0th index contains the maximum value. Okay, let us calculate it. First of all, I want to check whether from this, let me take any other color. Okay, so I want to check from this, okay, whether 0 is greater than the 10. Greater than 10. No. Okay, go here. Whether this 0 is greater than the 10. No. Just go here. Whether this 10 is greater than this 10. But it is what? We want to take at this time, we want to take the highest index, right? So I will update whenever there is a greater than or equal to. Instead of checking greater than, I want to check whether this 10 is greater than or equal to this 10. Yes. Yes. So I will update this as what? 3. The index is 3. Okay. Now again, I will check here. 0, no. 3, no. 0, no. 0, no. And it will be end. So what is our answer? It is 3. Hope you understand this, right? So what is the time complexity? It is O of n. And what is space complexity? It is O of n. That's it. Okay, let us see the code. So see here. So it is very, very simple code. You don't want to know any algorithm on graph. Okay. Now n is equal to len of exits. Now w is equal to weight. I am going to store the weight as I mentioned in the drawing explanation. Now for I in range of n, if that exit of I is equal to, is not equal to -1, then I want to proceed, right? What I want to proceed? Weight of exits of I, which means I'm just taking the value, okay, and at that value I want to update what? The current index. That's what we have done here, right? If it is take for example, if it is this like, then I want to update on this 5, which means the array of 5 plus is equal to 3. So I want to update that element for the index value. That's what I have done here also. Okay. Now result is equal to 0 and I am traversing one by one from 1 to n, and this result is what? Index. Okay. Now I am checking whether the current index weight is greater than or equal to the weight of the result. Okay. Now if it is so, then I will update the result as I. Then I am just returning the result. That's it. So hope you understand this code. Thank you.